Hello friends, I hope you have seen the previous video. If not, please find it in the top link. Now let's see a couple of more questions on Gay-Lussac's law. So here the question is, acetylene, that is C2H2, burns in air forming carbon dioxide and water vapor. Calculate the volume of air required to completely burn 50 cc of acetylene. Assume that air contains 20% of oxygen. So first of all, let's try and write a balanced equation. C2H2 plus O2 will give CO2 plus H2O. Here the water is water vapor, so we will consider water as well. So we get the balanced equation as 2C2H2 5O2 gives 4CO2 plus 2H2O. Here we are given 50 cc of acetylene, and according to the Gay-Lussac's law, this will be 2:5:4:2. So one part would be 25 and 25 into 5 would be 125 cc of O2 will be consumed or required. We have got interesting information that only 20% of oxygen is contained in air, and we are asked the volume of the air. Let's assume air to be X. So 20% of X is 125, and hence X will be 125 by 0.2, which will be 1250 by 2. This will come down to 625 cc of air, and this is your final answer. Now let's see the next question. On igniting a mixture of acetylene and oxygen, 200 cc of CO2 is collected at s.t.p. Calculate the volume of acetylene and O2 at s.t.p. in the original mixture. And that's a simple question. So let's write the balanced equation again, which we have already seen in the last So here the balanced equation will be 2:5:4:2. So according to the Gay-Lussac's law, it would be 2:5:4:2, and here 200 cc of CO2 is collected at s.t.p. Hence one part would be only 50 cc, and now acetylene accordingly will be two parts, that is 100 cc and 250 cc, and hence the final answer would be the volume of acetylene would be 100 cc and that of oxygen would be 250 cc in the original mixture. Now let's see the next question. Ammonia is formed from reactants nitrogen and hydrogen in presence of catalyst under suitable conditions. Assuming all volumes are measured in liters at s.t.p., calculate the volume of ammonia formed if only 10% conversion has taken place. Now first of all, let's try and write a balanced equation. So the balanced equation would be N2 plus H2 would give NH3, and after balancing it, it would be 3 and 2. So according to Gay-Lussac's law, we'll get 1:3:2. That is 1 volume of nitrogen plus 3 volumes of hydrogen will give 2 volumes of ammonia, which again means that 1 liter plus 3 liters will give 2 liters. Now in total we are using 4 liters and 2 liters is being formed. So the total ammonia that will be produced is basically, when we talk in the terms of percentage conversion, 10% of 2 liters, that is 10% of 2 liters would be 0.2 liters. and as per 100% we can say it to be 20% or 1 by 5. So this is your final answer, and this is a trick question, so please keep in mind what you are asked and how you are supposed to do this. Let's see next question. 100 cc each of water gas and oxygen are ignited and the resultant mixture of gases cooled to room temperature. Now calculate the composition of resultant mixture. So water gas is given carbon monoxide plus H2 in equal proportion. Carbon monoxide plus oxygen will react to form CO2. So this will become 2 and this will also become 2, and the other reaction would be H2 plus O2 would be H2O. So here it becomes 2H2 plus O2 gives 2H2O, and this will be liquid as the question is given, it's in the room temperature. And let's apply Gay-Lussac's law. 2:1:2 and 2:1. Now the given data is 100 cc each of water gas and CO and H2 are in equal proportion. That is, CO is 50 cc and H2 is 50 cc in the water gas, and we are given 100 cc of oxygen. So let's consider that later on. So one part would be, if 2 parts of carbon monoxide is 50, then one part would be 25 cc, and hence 25 cc oxygen will be required to form 50 cc of carbon dioxide. And here again, if 2 parts is 50 cc, then one part would be 25 cc, and 25 cc of oxygen will be consumed again. But the total oxygen given to us is 100 cc. So 100 cc minus 25 plus 25, that is consumed, will give you minus 50 cc, which is equals to 50 cc. So in the resultant you will get oxygen as 50 cc, you will get carbon dioxide as 50 cc, and that's the final composition of the resultant, that is the products. Thank you for watching this video. In case you have any doubts, please comment in the comment section and get those doubts cleared. Thank you for watching this video, and please share it, like it and subscribe it. Please don't forget to press the bell icon if you don't want to miss any updates from our channel. Thank you.